All right, we're back. We are COMP123 in the summer 2017 semester, and we are week 9, part 3 of our broadcast. Last day we did part 1 and 2. We talked about polymorphism, a little bit more of object-oriented programming. Today we're going to talk about abstract classes and interfaces a little bit more. And we're going to also talk about lab number 24, which is up on your Dropbox. If you actually look on Dropbox in eCentennial, lab 24, you're going to be creating a supervillain today, and it's due by midnight tonight, right? Worth 0.5% of your final grade, right? So due by midnight. And now you're going to put if you actually look at the details here, please look at the details for your lab. All the lab details are contained inside the description. So if you actually look at the description here, you'll see what I'm looking for and how many points are associated with every piece of it. It's not a lot, but more or less it's due tonight at midnight. So that's July 13th, right? And what I want to do is I want you to make this, using the superhuman example that I got in class, which I'm going to complete today. I want you to create a new supervillain class that should implement the I has malice interface, right? So after today, you should be able to do most of your assignment number 4, if not all of it. Points here, what I really want from your lab 24, which I'm going to explain, is 2 things. One, I need you to use zip to zip up your entire project archive. So not just one file. If you just give me one file, it's not enough, right? I want the entire project zipped up, not RAR. Don't give me a WinRAR. It's got to be zip, and you can download 7-zip for free if you look it up. So if I go 7-zip, right? If you're a person who wants to do it, you can click on download 7-zip, and you can see that there's 7-zip for Windows 64 and 32-bit versions. You can download. I recommend this one. It's free, and it does exactly what I want you to do. Okay? So that's the one part. And the other part is I want you to learn how to use GitHub. So I'm forcing you to do this, right? Each thing has a little bit of points. So for example, there's 3 points for the superhuman class. There are 2 points for the I has malice interface, 2 points for the driver class, how you're going to implement that, and 2 points for GitHub for a total of 10 points to get your 0.5%, right? I think in the past year, I think you had 9 points that he was looking at. So this is what it looks like for your lab. This is due again at midnight. And the only way you submit, I don't want to see anything. I don't want you to hand me papers. I don't want you to print anything out. It's all up on Dropbox. So please use electronic means of sending it to me, okay? So all through Dropbox. That's what you're going to do. Okay, so that's your lab. I want to go through the details of that in a second, how to do it. But I'm going to base it on what we've been working on last day. Now, last day we worked on lesson 9B. And I'm also, remember, every time we get together, I also want to, everything's going to expire, to talk about different aspects of Git every time we get together, because I want you guys to be very comfortable with Git and GitHub by the end of this semester, right? At least at the very base level. Last week or last day, we talked about 9A and for class 1 for the first section, and 9B for the second section. That's you guys. But now I'm going to switch to 9A for you guys. Okay, how do I do that? I got to show you this, right? How do I do 9A? Because 9B has all the implementation details. By the way, if you really want to use my 9B that I completed today earlier, you can. I'm okay with using that for part of your lab, because you're going to base your lab off of my lesson. That's what's going to happen, okay? You're not going to start from scratch. Your assignment's from scratch. Okay, so how do I do lesson 9A? I want to, in my local folders here, if I was going to look at my local folders, let's take a look. I have COMP123, but I only have lesson 9B, and I want to have 9A, and I also want to have all of the commits from 9A, right? I don't have them on my computer right now because this is my Mac. Before I was working with my Windows machine. So it's like I'm having a new machine. I'm downloading my project from GitHub onto a new machine. Okay, but for me to have all my commits and everything else, there is a command that I have to do, and I have to do it on command line. So here's how you do it. Now, for this to work, you must have Git installed locally on your Windows machine, okay? By the way, you don't have to do it this way. If you just follow along with lesson 9B from the previous lesson, or if you want to download and install 9A or start from scratch for your lab, it's up to you. I'm totally fine with it, but this is what I would do. Git commands start with the word git, right? In this particular case, what I want to do is I want to git clone. Okay, so that's the command, git clone. When I clone a Git repository, it comes from GitHub. I got to supply a path, right? and then it downloads everything locally into my machine. Notice that I also have to be in the right folder. Right now, I'm not in the right folder. I have to change directory to it. So the directory, the way we change directory in Windows, for those people who don't know, is CD, okay, change directory. And a really quick way to find the exact folder is just drag and drop like this. Whoop. And this works in Windows, right? And if I press enter, now I'm inside that folder. Notice that my path is users, Tom, desktop, COMP123, right? And this is where it is, right? So I'm sitting inside this folder right now. And this is where I want my folder to go. Okay, this is where I want my new Git repository to be downloaded to. Okay, cool. Next, I want to put git clone, but I need the path. I don't know. I don't have the path. I don't know it off the top of my head. It's going to be something like https://github.com, blah, 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 right? So I can get that from GitHub. So I'm going to go up to GitHub. And if I'm going to look at my 9a, and I encourage you guys to try this if you want to try, go to 9a. This is the other classes sections demo, which is slightly different than what we did last day, right? And if I go up here, notice that if I go clone or download, there is this clone option. So if I click this is the path right here that I'm going to clone. So I just need to copy this. I'm going to click on this little button here. Copy. All right, cool. Now that I've copied this, by the way, when I clone this is cloning my version. For you, you're just going to go on with your version from last day. Hopefully you followed along, right? But you can certainly download my version this way as well. Okay, now that I've got this version, I need to put this in my command prompt, and I'm just going to right-click and paste. So notice that this is the exact thing I'm trying to download. So git clone, and the path to my GitHub, so github.com/centennialcollege/comp123 S2017-lesson9a.git. Whew, I press enter. What it's going to do is going to go up to Git, grab everything, and download my project plus the local repository, so it keeps in sync with what I have up online. All right. So if you're ever changing computers, this is what you need to do. Right? Am I going to test you on this in your exam? No. I'm just showing you because I want to show you more things about Git. All right. Cool. So I've got this now locally. Here it is. Right. And notice I've got 9a, and this is the one I'm going to start with today. So please look to 9a when I do my updates to keep up. All right, so I'm going to double click on 9a, and I'm going to double click on the solution file to launch Visual Studio 2015. So Visual Studio 2015 is launching. I'm running it in an emulator, my virtual machine, right? Windows 10 virtual machine. And it's going to bring it up. So last day, what we talked about, we got to talk about a couple things, right? We created a superhuman class. That's what we did. So let's go to my Solution Explorer here to see. We created a superhuman class, and the superhuman class had a human class as abstract superclass, as well as a power class. And if I look at the class diagram, and it's almost exactly the same as what I did with your class, it looks like this. Notice that the power class has nothing to do, let's just reorganize things a little bit. So here's my human class, right? Here's my superhuman subclass. Here's my power class. Notice that there's no link between these, right? And if I want to, I can also drag and drop my program class. I'm just drag and drop that in there. Notice my program class, again, has no link because it's just the driver class, right? It doesn't have a dependency. The other classes don't depend on it anyway. So if I put it over here, as an example, it just floats around. There's no dependency, but this is part of my application map. This is my class diagram or my application map, my manifest, if you will, okay? Great, so there's these two classes. Now I want to create, right? I want to keep doing this stuff, and I want to talk about some stuff we did. One thing we did was we talked about this abstract class. So for people who remember from last time, review, what is an abstract class? We talked about this a couple times, but I'll ask somebody that I'm going to bug today. I'm going to bug you. So tell me what's an abstract class. Huh?
It's like the highest hierarchy. So most general.
Well, no, that's not the most. The abstract class, think about this as a blueprint for other classes. So when I put the abstract keyword in front of my class, it means that I can't, what's the difference between an abstract class and a concrete class? Those are the two words I use, right? Remember, abstract class is I can't instantiate an object of that type of class. A concrete class is I can instantiate a method. I can instantiate an object, right? So all regular classes that we normally are used to are all concrete classes. Abstract class means you cannot instantiate an object of that type of class. It's just a blueprint for other classes. All right? That's what the difference is. Also, abstract classes have certain properties, which we're going to get into today. Okay, cool. So the idea of an abstract class comes from the idea of polymorphism. All right? Now, what is polymorphism? What was that? Remember I gave you that Greek definition? What's polymorphism? Yeah. Many forms. I love it. Poly means many, right? And actually, you know, metropolis also comes from the word poly, right? Many people, right? Many people in a city, metropolis, right? A metropolis, right? So anyways, so if you think about it, right? Many forms, many shapes. And that's what I can do. I can take an original shape, the shape of my human class, and create another shape for my superhuman class, right? And I can modify the human's methods to further specialize them by using the override keyword, which I talked about earlier. Let's talk about it from a concept perspective. So I'm going to bring up my PowerPoint here. We also talked about something else. I talked about this object super duper class, right? Really briefly. And I said that this class, every other class inherits from it, right? Every other class inherits from it. And that means that the object class has been written by Microsoft, C#, right? And by the way, Java has an object class as well. It's a super duper class at the top of the chain, right? That's the top of the chain, right? And every other class we ever write or ever has been written has inherited from this class, okay? So what does this mean? Well, what it does is, as an example, I can do something like this. I can say, hey, my display object message method, right, requires a type of object. That means any class. That's what it means. Put any class in here and it's good, right? Any class that we create, any object of any class is what we're going to pass into this display object message, right? So if I pass my superhuman, right, the O would represent the superhuman. We're passing the object by reference. So the O now represents my superhuman. So I can say something like O dot display powers, right? Because O is it refers to the superhuman if I was going to pass it in here. Okay, so that's what the object superclass does. It allows us to do stuff like that, as well as it has 4 methods that are built into all all classes that we ever make. So the object superclass has equals, get hash code, get type, and toString. The most common use, all right, the one that we override the most is the toString method. Okay, so each one of these methods already has the override keyword and the virtual keyword built into it. Remember we talked about overriding previous methods, and back up here, if I'm not wrong, we had an example of where we overrode a method. Let me just go back up here. Keyword, parent base, and that's not it, but let's just go. I think we did it somewhere up here where I kind of said, hey, you can override something by making it virtual. I think I kind of mentioned that somewhere. Let's see where it is. But we need to use the virtual keyword. I think it's probably even further back. Yeah, it is. Remember, we used to use this virtual keyword. Here's the virtual keyword, right? And we want to make a method or a property that we want to override, right, in a subclass. So let's say, for example, in my parent class, human, I could have had a property that I attached the virtual keyword to, which means I may override. I don't have to, but I can override it and change it to further specialize. This is polymorphism, right? To further specialize my child class. That's what I do it for, right? So part 1 would be to add the virtual keyword. Part 2 would be actually to use the override keyword in the method that I'm overriding, right? Or property. In this case, it's the property. Remember we did this? And I said that the difference between this credits property in the scholarship student compared to the credits property in the regular student, right, is that it doesn't have both getter and setter. It only has a getter. So it's a read only, or I think it's only the setter. It doesn't have the getter, yeah. So it's a write only property, which is kind of weird, right? But that's the difference. We use override. Okay, well, taking that idea, right? Taking that idea, and I'm just going to go skip down here to the right slide. If we look at this idea of that object is a super duper class for all things, it has these methods that we talked about, and one of them that we want to override is this toString method. By the way, this is part of your assignment, I think, as well. So we're going to do this today. So how do I override it? Well, it already has the virtual keyword attached to it. I don't have to add the virtual keyword because this is not my object. The object superclass has been written by Microsoft, right? Or whoever created C#. So it already has, for its method, the toString method, it already has, and I want you to think about it, a ghost virtual keyword already assigned to it. All we need to do is override it if I want to use a custom toString method for my class. All right, that's what I want to do. So here's some examples of some methods that are the most common. I mean, this is pretty big, but I want to make it so you can see it. So the getType method is something where we can get the type of a particular class. Again, it's part of, so if I say, for example, whatever the class is, .getType, it'll actually show me the type. What is the class? Where does it come from? What is the class's type? Okay, that's pretty useful if you want to do some comparisons, right? But this one, the toString method, is the most overwritten method, right? So here's what it can do. We can say, hey, in my class, I want to use the override keyword to override the built-in toString method, so that way I can have a special effect in my class, right? Let's do that. So I'm going to go back to my code, right? In my Solution Explorer. Now, if you're with me, you're going to be around the same level as me, right? So I'm going to go to my superhuman class. Here's my superhuman class, right? And down in the bottom, right, I'm going to have an area where I have my public methods. It's going to be public, by the way, right? Because I'm overriding a method that exists. And I'm going to go down in here and basically define this method like normal, right? So it's got to be public, right? I need to use the keyword override, right? It's going to return a string. These are all things that happen. And take a look at what matches that signature. Boom, Microsoft comes up with a recommendation, toString. It says, hey, are you trying to override the built-in toString class, a toString method? And the answer is, yes, I am. So if I click on it, like this, then bam, it says return base.toString. Now, I don't want it to return the base. I want to create my own. Now, it's going to return a string. And for me to make use of it for my superhuman, I want to return not just the string, some string, but I also want to return kind of a string that I'm going to build up. All right, so how do I do that? Well, let's think about a couple things. One thing I want to do is I want to set up a local variable, let's say, and this is just the way I'm thinking, right, called output string. Right, so output string, let's assign the default value of output string to the empty string, right? And what I want to do here is I want to build up the thing that I'm going to return. So I'm actually going to return at the end output string. That's what I'm going to return. Now, output string right now is like an empty string. It's nothing, right? Which has no value. So let's make it so it's more interesting. I'm going to do something like this. I'm going to say output string, right, plus equals. This is using the shortcut operator. This is like saying output string is equal to output string plus, right? And then let's say the superhero name, right? So say, we'll call them the superhuman name, right? Plus the plus operator, plus the name, this dot capital N for name, right? Plus, anything else I want to add in, right? So let's say we'll add that in for now. So if I add this in, now it's going to add this in here, right? But one more thing I want to add maybe is a backslash n for new line, a new line character, right? So I want to go to the next line. That's the output string, right? Cool. Well, this is very nice. Let's add some other stuff. I'm putting up here. I want to add in some kind of decorator. So let's add some decoration to it, make it look a little nicer. Something like this. Maybe some equal signs, and then backslash n again. So kind of a decorator. And this decorator, I want to put it the same thing down here. Follow me what I'm doing. This is what it's going to output, right? You guys probably have done something similar. All right, cool. And this is good. This is just the name of the person, but I want his powers too, right? So I've already got that up here. But I can't really use display powers down here. I can't do that because display powers actually does a console write line, right? And it doesn't return a string. I'm not going to modify my display powers. I just want to do the same kind of thing. And it's good practice for you guys anyway. So I'm going to do a for each. And this one, remember I talked about this? It's going to be of type power, right? And it's going to be power lowercase. For every power in my powers collection, right? Here's my powers collection. I want to loop. That's what this thing is doing, right? Let's make a little space here just to separate this a little bit, right? So for each power in powers, I want to print them out. I want to say something like this. So I'm going to say, you know, my power, right, plus the power name. So power.name plus, right? I want to also have a space and then the rank, power rank, plus the power.rank. This should all maybe be familiar to you because we did it last week or last day. And then plus a \n. So for every power, it's going to add a new line in there. Okay, this is cool. But I want to add this to the output string. So I'm going to say output string plus equals, right? That's what I want. I want this string, as it loops through each of the powers, it's going to add on to the output string. That's what's going to happen, right? Okay, cool. So it's going to output this power. And then I want to kind of close it off with another one of these, right? So copy, and then go down here and paste. So that's the kind of the. I'm just gonna frame it nicely when it outputs. That's all I'm doing. Okay. Yay! But the exercise here is that I've overridden the built-in toString method. That's what I want you to think about here. All right, so let's add some comments here. So // so overridden the built-in toString method, right? That's what it does. Notice it also says, see, there's an actual section here that says returns. I can probably return something too. If I want to, I can say returns a string if I want to, so string. Weird, never give me that before, but okay. So this is just a little summary of stuff that it's done. And here's the toString method, right? So now this is something I just made. So what I need to do, GitHub, right? It's a great time to put up to GitHub. So Team Explorer, I'm going to kind of, you know, hit this one, go to changes. You can see that I've modified my superhuman class. Oh, wait, I modified my superhuman class, then my header should be modified too. So I'm going to go in here and go for, I'll say added, overridden method toString. Right, that's what I did. And I'll do the same thing. I'll just copy paste that. So copy, paste into my comments. To the superhuman class. And then commit all. So what this will do is it'll add the superhuman, this toString method to the superhuman class. Let's test it. And we're going to do that inside of our driver class, which is down here. So here's our program class. Our program class is the driver class. There it is, right? And we're going to modify this too. We're going to say use the toString method of the superhuman class. Right? And down in here where I'm going to use my method. So I displayed my powers. That's cool. But let's not display powers this time around, right? We're just use the superhuman.toString method. Now we can't just use it. We can't just go superhuman.toString. Why is that? Why won't this work for us, by the way? Well, remember, toString returns a string. So it's going to go to the bit bucket in the sky. It's going to go into the sky. It's not going to go anywhere because nothing's receiving it. I can call it, but unless I'm doing something with the string, it just goes nowhere, right? So I have to pump it into like a command console write line. So if I go to console write line, right, and if I take this thing here, the output of my superhuman toString, and I put it inside here, right? Then what I'm doing is I'm calling a method. I don't need a semicolon. I'm calling a method toString, and its output is a string, which is going to go to the write line, right? Which is going to go to the console. So now when I do it, to give you an idea, and if I press Control F5, then I should get, if I'm right, this superhuman name, superdude, power, teleportation, rank 50. Okay. If I want to add another power to it, I could do that too. I can kind of add another power. So he's got teleportation. This got a different kind of super guy that we made here. He's not the spider guy that we were doing before, right? He's got teleportation and phasing, Okay, he's going to phase through walls, so you can pass through walls. Hey, you know what? And let's make it so it's not as strong. Just to give it an idea. And you know what? We're also going to add in, just by chance, to make it a little different. So because I'm not a robot, I do different things from different sections. He also has invisibility, so he can, it's like a ghost guy. It's invisibility, phasing, and teleportation. That's kind of a weird power set. Okay. And let's say his invisibility is a 30, so it's not quite as good. It's not perfect invisibility. It's kind of a camouflage more than anything else. All right. All right, cool. And then let's say again, we're assuming that the ranks here are out of 100, where 100 is perfect and 1 is terrible, right? Okay. So let's just take a look at this. So I've got a few powers now, and if I go Control F5, right? So I can do the same thing. Then I should see this: power, teleportation, rank 50, power, phasing, rank 40, power, invisibility, rank 30. And all this came from the toString method that I called and I overrode, right, which is part of the object superclass. That's what I want you to get from this part, okay? So things to note about the object superclass and the toString method is it just outputs a string, and you have to pipe it into somewhere like write line. Okay, write line just takes a string, right? And that's what is returned by toString. Okay, cool. So we've done that part. And we modified this, right? So we might as well put it up to GitHub. So I'm going to go to team. And I modified it. So I'll say use the toString method of the superhuman class in the driver class. This is our test harness kind of thing, right? Commit. I'm not going to push it to GitHub yet. I'm going to push it later. Okay, cool. So I've got this. And now let's go back to that stuff here. So we understand how to do this now, right? So we have to use the override keyword. Remember, we don't have to use the virtual keyword because the virtual keyword has already been used in the object superclass we didn't write, okay? Next, there's also something called equals, where you can compare one class or one object of a class to another. Now, I'm not sure how that would work for us because we're comparing one to the other. You want to see that they're exactly the same. You'd have to have some kind of way of comparing them, right? How do I compare one superhero to another? Well, you'd have to compare superpowers, different abilities, skills, whatever, right? But we're not doing that, so this wouldn't apply. But if you wanted to, you would have to. If you wanted to override the equals method, you could. But if you override the equals method, you also have to override the get hash method, get hash code method, because the get hash code method is actually a hash code. There's a special number for each object that's ever been created. It's actually a number that's been generated by the system, right? And it's kind of an identifier for each object that's out there. When you use get hash code, it tells you what that object is. So you have to modify this one as well, and that's why I'm not going to do it here. A little bit more complex. I'm not going to ask you to do it on an exam. The only thing I want you to know is that there are 4 different methods that are built into the object superclass, and those are get type, toString, equal, and get hash code. Those are the ones I want you to know. So every object that exists and every class that exists in C# has those 4 at the minimum. Okay. All right. Moving on, we also want to talk about the idea of base class constructors, and I've already done that. We had this idea of a base class constructor last time, right? Because if you realize, we have to satisfy the base class constructor. What does that mean? Well, here's an example of an employee. Employee, right? You have the employee constructor. It's an empty constructor, right? It just has this little console write line, right? It doesn't ask for any parameter. And so when I make commission employee, I can just call commission employee and there's no issue, right? Because both of them are kind of the empty constructor and all I do is console write line. But in our example, we didn't do that, right? Superhuman is derived from the human super abstract class, right? And human requires a name, right? So therefore, superhuman requires a name, right? And I have to modify or use the base keyword to access it. And I think they give an example here further down. Here's the base keyword. So base, remember we talked about this? The base keyword refers to the superclass's constructor, where we pass in values that are required by the superclass. Now, what does that mean? Well, let's take a look at our existing class. So if we look at our Solution Explorer here, and if I go to the human abstract superclass, right, you can see that I have a constructor that takes in a name. And I did this dot name is equal to name, right? Here's my superhuman, right? And in order for me to comply to the humans constructor, I got to do this. But notice that I didn't do this dot name is equal to name in here. How come? Because it's already been done for me in my human. Human does all the work. Human does all the legwork, right? Human does this. I send the local variable that I pass in to the data field, right, through the property. That's what's happening here. So I don't have to do it again. I don't have to do that again here. I only just pass in from one constructor to the other, because then it satisfies the requirements. And that's what the base keyword does for us. When I create a non-standard or non-empty constructor that takes arguments, I must satisfy the superclass's constructor, right? If it has any arguments that it takes. If mine takes arguments, but the superclass doesn't take any arguments, it's okay. I don't have to use the base keyword, right? I only have to use the base keyword when my superclass takes arguments. I got to satisfy those arguments, right? Somehow, by taking in the requirements. But when I construct my new object, it also is constructing an object of type superclass, whatever that superclass is. So I need to take care of those requirements. And that's what this means. Okay. All right. We talked about abstract classes. And we also, here's the exact definition here. So from a test perspective, I asked you what it was. Again, number one, you cannot create concrete objects from an abstract class. All right. Concrete objects can only be created by concrete classes. And the difference between concrete classes and abstract classes is, think about the concrete class as just a regular class, right? It's not an abstract class. That means I can create instance objects, or if you want, instances of the concrete class. Whereas an abstract class is just a blueprint for other classes. Okay. Number one. Two, you use the abstract keyword when you make an abstract class, right? And this is neat. Usually contains abstract methods, although methods are not required. And I didn't make it required, right? In our human class, we don't have an abstract method. Now, this is neat. Abstract methods override them. All right, there is no option. If I declare an abstract method in my super class, which is also abstract, the class that derives from it, the child class, must override them. Okay, so abstract method, as an example, what can I think of as an abstract method that I can have implemented in my class? Well, let's suppose that all humans have skills, right? Like gymnastics, hunting, right? Martial arts. Humans have that, right? You don't need to be a superhuman to do all those things. You can go to class and learn stuff, have math skills. Those are all things that you can have, right? Uh-oh, skills is like another data type, like powers, right? So if I was going to make a skills list, I need a skills or a skill class. We're not going to do that today because we have no time. But the idea is that that's what I want to do. So if I want to implement a skill, right? So I want to have display my skills, right? And if I make that method as part of my human would have to override it and have to redefine it. And see how that's done. Okay, so here's my human. Now this is the problem. Remember I talked about, good things and bad things about inheritance? Here's the bad thing about inheritance. I'm going to show you, right? Yay, I've got my little class in here, and I have to add some methods. So let's add a method, right? And I'm going to add in an abstract method. Now, when you add an abstract method, you do not define the method body, just the method signature, all right? Which means I would do something like this: public, right? And then let's say it returns void, but it actually does display skills, right? So that's the first part. Now I'm going to notice that if I just put a semicolon now without the abstract keyword, it gives me an error because it's expecting a body, a method body. But if I put the abstract keyword in here, now I've really done it. Now what I've done is I said, look, you know what? I've listed an abstract method that must be overwritten or by my child classes. So this is not just methods. These are public abstract methods, different kind of category, right? Public abstract methods. And these public abstract methods, this is the display skills method that must be overwritten. Okay? Uh-oh, I've modified my superhuman class, or my human class. So this is, right? Public abstract method display skills. Okay, cool. Let's add that to my commit, because that's the one thing I changed. So I did that. So I'll say added public abstract method display skills to the human abstract superclass. Again, this is too long for what we normally want in GitHub. We want a shorter commit, but it's okay. Commit all. I'm still not putting it up on GitHub. I'm going to show you. You can do multiple ones. Okay, so this is good. So I've got this. Maybe I can add some comments here as well, but I'm not going to. I'm going to go to Superhuman, and oh my God, I got a problem. Look, Superhuman says, "Whoa, man!" It says Superhuman does not implement inherited abstract member human.display skills. Now imagine if I had not just Superhuman, but lots of other subclasses that came off of Superhuman, like Supervillain, Superhero, Vigilante, blah, blah, blah. Keep going. I can keep making them. Specializations, right? All of them would have to be modified. This would be very bad. Okay? So what we're going to do is down in here is I'm going to implement the new abstract method, right? And we're going to do that by overriding it. So this is public overridden methods. Actually, I already have that for my, I might as well put it up here, right? Because I already have it for my toString, right? Public overridden methods, right? So methods that have not been made by me or from another class, whatever. And then this one here is going to be public. It's going to be overridden, override, right? Void. And if you look at it, what it gives me, Microsoft is beautiful. It says, hey, the only one that matches that kind of signature is display skills, right? It knows because I made it, put it inside my abstract superclass human, it must be overwritten here. So if I double click, it also gives me this method stub, which is really ugly. Throw new not implemented exception error. I don't want that, right? Better to put in something like this. Now, I'm not going to implement this method here today. I just wanted to show you that what I need to do if I want to conform to the abstract superclass human, right? So I'm going to do a console write line, and I'm just going to put not implemented. Okay, so I'm not going to throw an error. I'm just going to say not implemented here. And down in here, I'm going to say // this is the display skills method. And I can put something like needs to be implemented. Really implemented. It's just a stub, right? And you can work like this. You can actually create all your methods ahead of time, and then go back and then after they've been scaffolded, you can go there and then flush them out if you want to. But we've made a change to our superhuman class, so I'm going to go up here and I'm going to say something like this. So 005 or 05. I'm going to say added stub method. That's what a stub method is. A stub method is a not implemented method. It's just a stub. It's not. It's just a. It's empty. It's not ready. It's not really ready for production. All right. Added stub method display skills to conform to human abstract superclass. Conforming to that because the abstract superclass requires me to override it, so I'm just doing it. Okay, that's all I'm doing. Okay, cool. So now that I've done that, I need another commit. So I'm going to go here. And instead of typing all that out, I'm just going to go whoop, grab all this, copy. I'm going to go to my Team Explorer and paste that in, right? Display skills to the superhuman class. Conform to the human abstract superclass. Commit all. Okay, cool. I've got lots of commits. Great time to push up to GitHub. And you guys can follow along this way too. So I'm going to go to home. I'm going to go to sync. And if you notice, I got these 4 commits. I'm going to push. Right now, this is going to push everything up to GitHub. Yay. Let's take a look at GitHub now. I had 10. And now I don't have 10 anymore. I have 14 or whatever. And you can see that these are 4 of them from today, July 13th. This is from last day, July 11th, when we're here. And it tells me, look, even when I did it earlier, like 17 minutes ago, 13 minutes ago, 4 minutes ago, 21 seconds ago, Even if I don't put them up to GitHub, it keeps track of the time that I made that commit, all right, locally, right? And it matches it up so it's in sync on GitHub with what it is locally on my local machine. Questions so far about GitHub and about what I've just done? No. As long as it's in your project, you're good. You won't lose anything. But you will want to sync it at some point. The reason why we use GitHub is for 3 reasons. I'm going to put this on your exam: backup, collaboration, and version control. If you don't put those 3 things up on GitHub, or you use GitHub for that reason, if you don't put stuff on GitHub, then you miss out on the collaboration, right, for sure, and backup. You miss those 2 pieces. That's why you need to use GitHub. Git is only one part of the whole version control system solution, right? Local Git only protects you if something happens to your code. You can always go back locally, right? But if your machine dies, then your code is gone, right? And that's why we put it up on GitHub. All right, so yay. So this part's all been done. We're ready to go. And you know what? Let's test it. You know, we've tested it here just to make sure. I like testing it again. I'm not changing anything. I just want to test it again to make sure we've made this change. Whenever I make a change, I always want to test my code to make sure it didn't break anything, right? Because breaking something would be very bad. It chose the wrong one. So this is what this does, right? So it still does this, which means we're still good. Every time I make a change to my code, I want to test, right, to see if the things are good. So I don't go too fast. All right, so we've done this part, abstract classes and methods, right? And this is an example of the animal class. So here's my abstract animal class. And here's a method that's just the signature, right? Speak is the method signature, right? Speak has no body. There's no body in the method itself. Just the signature itself. Signature means just the line with the semicolon and the abstract keyword, right? And then in my dog class, I'm overriding the speak method, and I'm adding a body, right? In this case, it's woof, right? And for cat, it's meow. But both methods are more specialized, right, than the original one, because in the abstract superclass, there was no definition for what's inside the method, just the signature itself, right? And now we're actually putting the implementation details here inside of the subclasses or the derived classes. All right. And let's just implement how to implement them. Excellent. All right. Someone this morning said, so multiple inheritance. That's what, when we use interfaces, it's multiple inheritance. But actually, there is no multiple inheritance. And if I was going to ask you a question on an exam, you know, is there multiple inheritance in C#? The answer, true or false? I would word it like this. There's multiple inheritance in C#. The answer is false. There is no multiple inheritance in C# because the concept is really difficult to understand. How do I inherit from 2 different classes? What happens if I have the same method in 2 different classes? How does that clash? You know, there'll be so many other issues with that. So we don't do it in C# and we don't do it in Java. Okay, we don't have multiple inheritance. There are other languages that allow it, but those are different kinds of languages that serve different purposes, right? So in order for us to overcome that, because sometimes we want kind of properties from one class and properties from another class, kind of, I want to include them both in another of the class, we can use something called interfaces. And we've talked about interfaces before. Interfaces are, you make a contract, right? It's like an abstract class, similar to an abstract class. But what an interface does is you subscribe to an interface, right, in your class, in your subclass, and you must override any abstract methods or properties that are defined in that interface. Okay, must override. So what do they look like? Let's give you some examples, and this is going to help you do your assignment. Here's an example of an interface: public interface I workable. Notice that there's an I, right? I means interface. Workable usually has something to do with the method or properties that you're going to be adding into your class that implements the interface, right? What does it say here? In an abstract class, not all methods need to be abstract. And I gave you that example in human, right? In an interface, all methods are abstract. So therefore, all methods must be overwritten and must be included inside of that class that you're implementing, okay? So if I have a method called iWorkable then, and if I have an employee and I implement the iWorkable interface after the colon, right? then I must override the work method by defining it. Notice the absence of abstract here. There is no abstract requirement here. You just need to define the work method. Here, we didn't define we didn't put virtual, right? We didn't put abstract. And notice also that there is no access modifier. There is no public, because the default for interfaces is public. Please be very careful, okay? Here, right, we have two examples, right, of employee and animal, right, both using iWorkable, right? iWorkable, work for an employee, I do my job, and maybe for the animal, it's going to be, you know, bark, bark, bark. I don't know, whatever they're going to say, right, for the animal, but it's down in here. Okay, so these two things I want you to see, because I want you to understand that both can implement the iWorkable interface, but they're totally different kinds of classes. Wow. Okay, so we want to do something here, right? And this is the part the first part to getting down your lab, right? I'm going to make a superhero, right? It's a specialized version of my superhuman, right? Superhuman is just a generic superhuman, but they have no moral compass. Think about them as, I just got superpowers and I don't care, right? But a superhero might have some kind of moral compass. Maybe they don't like to kill. Maybe they like to help people. Maybe they want to get points in a game, let's say, for helping. Let's call those points karma points, right? So as you do things that are good, superheroes gain karma, right? So I'm going to make the I has karma interface. I need to do that. And then I'm going to create the superhero class that's derived from my superhuman superclass, right? So this is the inheritance chain that we're going to create. Let's do it. So inside my class diagram, this is what I want. This is where I'm going to do this, right? What I'm going to do is create my interface. So I'm going to add my new interface. And this is what I want you guys to do for your assignment 4. All right. So my interface is going to be called I for interface. And then in this case has karma, right? Because heroes have karma, right? They have this moral compass, let's say. It's green. And notice that there's no links to anything else here, right? All right, cool. So I'm going to kind of put this up here. And what I'm going to do is I'm going to expand it. So I want to do this. I'm going to double click on I has karma, right? Here it is. And inside my I has karma, oh man, it's a new file. So what do I need to do? Do one of these, right? I want to put a new header on my file. I recommend this for you guys as well. Oops. Be okay. Go back to the I has karma file here and put that in there. It's not July 11th, it's July 13th. So we'll do that. And it's not the driver class. This is the is an interface that basically one that defines a karma property that, let's put that down here, must be implemented in any class that subscribes to it. I say subscribes to it because you really subscribe to an interface and you implement it. Okay. So here, instead of version 0.3, it's version 0.1. I'll say created the interface, which is I has karma interface, right? And inside there, what I want to do is, this is where I define, and again, I could actually further go down here and do // and then this is the I has karma interface, put other details in here. I wouldn't just put this, I might put other details about what this is about, right? And then in here, in my I has karma interface, I'm going to define a property. Okay, now I need to make it, instead of public, I'm not going to put public because I know by default it's public, right? And I'm going to put in the property. So the property is going to be what? Karma is going to be an integer, right? And it's going to be called karma, right? And I want to make it a property, right? So I'm probably going to have something like this. So a getter and a setter. Okay, cool. Uh-oh. If this is my public properties, so public properties for my interface, can I also add in a private instance variable? Did I say we can do that? No. But let's try it. See what the difference is. So here's my private instance variables. let's make a private instance variable called int, private int and underscore karma. That's our style, right? Well, you're going to see that Microsoft's going to complain, right? It's going to say, whoa, guy, what are you trying to do here? This is an interface. We're not really defining anything here. All we're doing is declaring signatures. That's all we're doing in an interface. We're just making a contract, right? You're defining an actual data value, a field, and that cannot be done. So interfaces cannot contain fields. End question, right? Interfaces cannot contain fields, right? Because interfaces just really define like another blueprint we're gonna create our specialized class, right? Okay, cool. So we've got our interface. Wonderful. Guess what I'm gonna do? I just defined my interface. I'm gonna go to Team Explorer, right? I'm gonna go to Home. I'm gonna go to Changes. Notice I've done this. I'm gonna say added I has karma interface, okay, and commit all. Wonderful. Now, going back to my class diagram. So this has been defined, nice, but there still isn't a link anywhere, right? And you can see that there isn't a link between this, and in fact, there never will be. This is just a definition, right? Now, what I want to do is I want to make a superhero class, which is like the superhuman class, but also it implements the I has karma interface, okay? Both things. So now you're going to see two things after the colon. The superhuman, comma, that's the syntax, and then the interface that I want to implement. Okay, let's try this out. So I'm going to right click, I'm going to add a new class. We're going to call it superhero. There's a superhero class, right? And I'm going to double click. That's just a stub. New file. So put that in there, right? There's my superhero class. And I'm going to put in version 1.1. And this is the superhero class, which inherits from the superhuman class, different, and implements the I has karma interface. Okay, this is July 13th. This is version 1, created the superhero class. That's what I did here. Created the superhero class, right? And there's my superhero class. I can further define another little comment for that, right? This is the superhero class, and I'm not going to go into more details here, but you can if you want to further give more details. Remember, we don't want to over comment. That's bad too, right? And in here, what I want to do is define that my superhero class derives from my superhuman. So I'm going to use a colon, and then superhuman, right? Comma, and then I has karma. And notice I got two problems now. Whoa, man. I got two errors, right? The first error is I have a custom constructor that's inside of my superhuman class, right, that I have to satisfy. That's number one. So before I start anything else, what I want to do here is I want to do this. I want to say private instance variables or fields, whatever you want to call them, right? I want to do public properties. So I want to kind of set up these things here, right? Constructors, private methods, if any, right? Public methods, right? So I want to kind of set up some of this stuff here, this structure for me to start putting in my code, right? It organizes things in my head when I code, and I want you guys to do that too, right? I want you to think about how to do that. So I know I need for my superhero to satisfy the superhero class because I'm inheriting from superhuman. Superhuman requires a constructor that takes at least a name, right? So I'm going to do that. I'm going to say public, right? Superhero, and it takes in a string that's a name, right? And to satisfy that, I got to send it to the base class name, right? I want to send the name to the base class constructor. So that takes care of one part. And this is the constructor, so I can just put in a couple forward slashes here to define the details here, So this is the main constructor for the superhero class. It takes one argument, name now, which is a string. Now this is going to change. I'm going to change this up. But if you notice, this is all I've done. So I've got this part. I've already satisfied this piece, right? Superhuman, because I've passed in superhero, the name, to the base constructor, superhuman. And I don't have to do that here. I don't have to say this name is equal to name because it's being done way back in human, right? Cool. That's done. Now I got to do the other piece, right? This other piece is this. And if I hover over it, it says superhero does not implement interface member I has karma.karma. I need to create that property, right? So I'm going to do that here. And just to be prepared, I'm also going to create a field. This is not in the implementation requirements, but I want to do it because I want to store things separately. That's my style, right? So I'm going to say private, right? And it's going to be an integer. And we're going to say underscore karma for private. And then in my public properties, we're going to say public, right? And then it's going to be integer and then capital K for karma. And what I want to do here is I want to have a getter, a separate getter, and a setter, just like normal. Notice that, oh, notice I'm making errors. Notice that I have no issues anymore. Notice that this is satisfying my requirements now, right? Now let's finish this off. So I'm going to return this dot underscore karma. That's what I'm doing here. And I'm going to set in my setter, I'm going to say this dot underscore karma is equal to value. Guys and girls, I've gone through this getter and setter process over and over again. And if I ask you to do something like this on a test, by now, after seeing it so many times, you should know exactly what I'm asking for. Okay? All right, so karma, I've got this, I've implemented this, and I've got my superhuman, right? I don't have to have any special methods right now. I could later on if I want to add them in, I can make specialized methods. But for now, I've satisfied my requirements. My superhero is complete, right? The default superhero is complete. Okay, cool. We added a superhero. What are we going to do? We're going to, and I've made a lot. I could have actually broken that whole superhero creation step into a bunch of commits. The superhero stub, I added the constructor, I added in the my properties, I added in my fields. I could have done all those separate commits, but I'm just doing one. So I'm going to say added superhero class. All I've done, because this is where we create the superhero class up here, right? And commit all. Yay. Let's take a look at the class diagram now. Here's my class diagram. Hey, take a look. This is interesting, right? I have a connection. It shows a relationship between superhuman, and superhero. And there's this little thing here, like I showed you on your assignment, that shows I has karma, right? This is the I has karma interface if I want to double click on it. And for me, the class diagram is really a map of my application, right? Which I really favor because I'm a visual guy, right? I want to look at stuff, I want to see where everything is, I want to understand all my applications. And it doesn't matter if you're inheriting a piece of code and you drag and drop all your classes in here, right? You can really understand the relationship between classes, which is really important if it's not your code. Now this is my code, but it doesn't matter. I like to understand what's happening here, and I'm just make some space here. I'm just move this over. My class diagram. There we go. Right? Just so you guys can see what it looks like, right? And this is what it looks like right now. So human, superhero. Let's test it. So I'm going to go into my program class. Here's my program class. And I've got this superhuman, but instead of superhuman, let's change the words from superhuman to superhero and see if we can do this. So I'm going to kind of do Control F and look at anything that says superhuman, right? I'm going to change to, you guys ever seen this? I'm going to change to superhero right here in this class, right? So superhuman is going to change to superhero. Let's us, if it says replace all, right? 8 replacements. Thank you. Instead of making superhero capital S, right? So it's kind of a superhero. Superhero is equal to new superhero. That's kind of weird, right? I want to kind of make this all lowercase. I want to do that really quickly so I don't have to work too hard. All right, so now it's a superhero, right? So if I did everything right, this is perfect. Let's make another little wrinkle on the superhero. One more wrinkle. I'm going to say that the superhero's constructor also takes a comma value, right? So we need to kind of load it in with some good things that he did or she did, right? So it's kind of a default value for the superhero's comma, right? So let's go back to superhero, and I'm going to modify it. I'm going to say modified constructor to take comma value. Again, you can say whatever you like there, something like this. So there's my constructor. Notice it only takes the name and it doesn't do anything down here. So I want to kind of take the comma value too. So I'm going to say int comma, lowercase k, like karama, lower comma. And then down in here for the first time, I'm going to say this dot k, capital K comma is equal to karma. All right, cool. So I've taken in the karma value, right? But now it kind of breaks my program because the superhero dude also needs a karma value, which is like, let's say 20 karma. So he starts off with some, instead of super dude, we'll say superhero dude, just to make him so we know it's the superhero we've created now. The superhero dude, right? Okay, cool. We use the toString method to the superhero class, but now what we've actually done is we've not the superhero class because it replaced this for me, right? I did a replacement, that's why I took care of it. So point 4 is we implemented the superhero class. Implemented. Right? That's what we did. I'm going to just copy that so when I do my commit, I don't have to work hard. So I'm going to go back to Team Explorer and I'm going to go here in the driver class. Right? And I'm going to commit all. Right? Yay. There we go. And I didn't mention that we modified my constructor. That's okay. Would I have done a commit? Yes, I would have. I don't have any time. I'm running out of time here. I want to give you guys time in class to do the supervillain, right? And let's test it. So I'm going to go debug, and I'm going to go Control F5, and there's an error. This is important to understand, right? So what's the error? Let's take a look at. No, that's not what I want. Let's see the errors. It says expected this. Okay, what did I miss? I probably missed a semicolon somewhere. Yes, I did. Here's a semicolon. Okay, cool. Save. Oh, and that was in this superhero, right? I'm going to make it. So I'm going to modify it. I say I fixed the problem that I had. Online would be a problem. So fix constructor error issue. Right, and then I'm going to go into my Team Explorer and I'm going to say fixed constructor in the superhero class, right? And I commit all, yay, yes, and now that's why I told you that's why I like to test. I didn't test enough. Control F5, and we're good. Superhuman name is superhero dude, right? Power, teleportation, all this stuff is regular. But now it just works like normal, right? Now, if I wanted to print out my karma, because that was one of the requirements for your situation for your supervillain, I could just do a console write line. I'm not going to redo everything right now. I could do a console write line and the superhero.karma, right? I could do this. I could say something like, right, plus whatever the superhero karma is, right? So this is, I'm not going to do a commit here for this one, not yet. And I'm just going to do a run debug kind of thing. And the karma value is 20. Okay, so it has all the, all the details from the superhero, plus it has all the abilities of the superhuman and the human. Human is the name, the superhero is the powers, right? Sorry, the superhuman is the powers, the superhero is the karma, right? And it's inheriting from the I has karma interface. Your job, right, is to make a supervillain, right? You're shaking your head, right? You're like, no, we're not. The supervillain doesn't have karma, right? He or she has malice, right? Malice is the opposite of karma, let's say, right? We're just making this up. And malice, you get malice points for doing bad things. like robbing a store and killing people and all that kind of stuff, right? That supervillains like to do, right? And so supervillains and superheroes are kind of diametrically opposed in their moral character, right? That's the only difference. So I don't want you to inherit from superhero. I want you to inherit from superhuman. We'll make another type of superhuman, a supervillain. And that's your lab for tonight, due by midnight, okay? I'm going to put this up on GitHub, and I'll let you guys, for the remainder of session, work on your supervillain subclass, okay? And you must create an I has malice interface. I has malice interface. Very, very simple, okay? And then I'll go around and take questions in a second. So one thing I did with my changes, right? I do have a change in my program class, and one thing I did was I just added, output karma value, right, in the driver class. And I'm not going to put an update there. I'm just going to go commit all, right? I'm going to go home, and then for you guys to have everything, I'm going to go sync and see all these commits and push. So now you can see how I develop, right? Every time I do something, I push it up to GitHub, and this way it's a good opportunity for you guys to see kind of like a map of all the things that I've done. It seems like there's a lot here, but they're little micro commits, right? They're little micro changes, and I can always go back and check everything that I've ever done, right? So it really gives you a map of everything and real accountability in your jobs. Okay, that's it for me for today. I'm going to go around and give you guys a chance to work on supervillain, and then we're going to see everybody next week. Remember, the supervillain lab 24 is due tonight by midnight. It's a solo lab. You're not supposed to do it with anybody else, but you can base it off of my code that I just gave you, right? But please base it off of the code that I did for lesson 9A or 9B, either one, doesn't matter. And then add in your own code for supervillain and your I has malice interface. Okay, that's it for me. Let's stop recording. We'll see you next time.